Okay, so I think I'm streaming. Ooh. Okay, hold on. Okay, I'm trying again. We are not receiving video data at a fast enough rate. Okay. So your connection is fast enough, consider using a lower bit rate. I think I need to change my bit rate. So just bear with me for a moment. This is the first time I've used this method. I'm not sure what happens when I broadcast an alert. Okay, stand by, folks. I think I can change this. Okay. I'm gonna try this again. I'm still trying this. All right, is anybody there? Is this working? I can't tell if it's working yet. It says I'm streaming. Let me check the, let me check something. It says live now. It says yeah. Live now. Yeah, it looks like I'm there. It's, okay, great. Okay, so here we are. This is, I'm Matt Taylor. Thanks for joining me. We're going to continue building HTML systems. We'll be talking about the Minicolumn competition today. Please excuse any technical difficulties we may be having, I may be having, because certainly the YouTube live thing is totally new to me. Twitch was a lot easier, so I've got a few things to learn here. So hopefully not a big deal. So let me first move to, I've got a lot of new tools, so here's what we're gonna be talking about today. Well, here's where we've been and where we're going. Last time we talked about all these things down to the Minicolumn competition. So I'm gonna, quick review over this stuff, and but we're not gonna go back and try and rewrite any of it. I know you probably can't hear me as well over here. I'm not gonna try and rewrite any of this stuff, but we're gonna focus on the Minicolumn competition, describing that, and then maybe get into learning and duty cycles. The duty cycles isn't complete. We've only done active duty cycles. We haven't done overlap duty cycles yet, which both will be necessary, I believe, to implement boosting. I'm not quite sure about overlap duty cycles. I know I investigated them a couple of years ago, but I'm not certain why they're used. It's probably for boosting. That seems to be the reason. But there's some interesting visualizations we can do with the overlap duty cycles, similar to the active duty cycle. Anyway, we're not going to do any coding today or creating diagrams. We're just going to try and do prose. But like last time, if we run into a situation where we need to update a diagram, I'm not afraid to go into the code and update it. So this is where we've gotten to so far. We're going to work on this competition first off, and so we'll start there. All right. I'm also going to turn on Discord voice chat. So you can see me on Discord, hear me on Discord. If you don't know the way to get to Discord voice chat, let me copy the link and put it into chat. All right. So let me know who's there. We got 5 people watching, it looks like. So thanks for joining in. We're gonna get right to some technical stuff, and let me know if there's any issues. Can everyone hear me? I just want to make sure that I'm coming through. If someone could say something in chat. If you're watching on the YouTube page, the chat channel is like right nearby the video. And otherwise, you can also get on Discord and that link that I just posted in chat and let me know there. There's a live streaming channel, or just get into voice chat. Hopefully everything is going well, because it's hard for me to tell. My control room is much different here than it was on in a Twitch. So let's see. I think I can see. Yeah, okay. Right, so let's go to the screen. I've got this server running. If you've been following along with me, you know what you're looking at here. If not, there's a GitHub project that you can follow along with. This is all the code I'm pushing is being pushed into this project, which you can see right there, even if you can't see the chat down there. It's called Building HTML Systems, and this is currently what it looks like. This is the spatial pooling page. This is going to be an interactive tutorial on how to create a spatial pooler, why it exists, what it's doing, how it's doing it, and how it relates to the neurobiology of the neocortex. So we've already talked about mini-columns. I'm not going to review this stuff. We've got placeholders here for certain things, like this is a diagram that doesn't exist yet. I'd love to make that happen, but haven't gotten there yet. This is the data that's being displayed or being encoded and input into the spatial pooler. And this is the encoding split up into its parts or all together. Here's the potential pools diagram. Given a mini column, each one has a different potential pool, and you can tweak this and change it. We're going to keep it at 85%. I've got a little code in here. Oh, actually, before we move on to the mini column competition, we are missing something in permanences. So we have a description here where we're introducing the term synapses. The first time we've talked about synapses in this document as scalar permanence values. That's how we model synapses. But we have not talked about how initial permanences are created. Well, we've barely talked about how initial permanences are created. We haven't talked about the mechanism we're using. So that's what this distribution here is. This is a normal distribution around a center point. And so that's how we want to set up the synapse permanences. We want to choose a center point, which I've chosen 0.5, which we can move around if we want, and that moves the distribution like so. So I have some code that's doing this. Given a center point, it will create this connection distribution for each mini column. As you can see, each mini column has it's randomized, so they all have different initial permanence settings. The more mini columns we get, the more sort of normal this distribution gets. So for example, I should be able to go into our code here, and I think I have like a size in the state here, the SP size, or do I? I might not. But we should be able to control the size of the spatial pooler. Here's where we're creating it, mini column count. So I have that set up as just a global page variable. I should probably pull that out into a state at some point, but I won't. But I do want to show you that when I increase this, if we increase this, we probably want to increase the winners, but I'm not going to worry about that. We should see this distribution. Oh wait, it's actually the input size that matters, not the mini. So you see the number of mini columns increased here. That's not actually what I wanted to do. What I wanted to do was increase the size of the input. So I can do that by increasing the n values of our encoders here. So for example, I'll just increase the scalar encoder by a factor of 10, and we should be able to see that distribution change. In order to do this correctly, I'm going to have to, this is a little bit of a code smell. I'm going to have to go into the combined encoder because it also is initializing its own encoder, but I'm not too worried about the code smell at the moment. So this should still work. So now our input space is much bigger, as you can see. The combined encoding is much larger because the scalar space is taking, the scalar value is taking up a much larger space. Hello, Falco. Hopefully you can hear me. So I'm just showing this. We're going to talk about permanences and the initial distribution of connection permanences or synapse permanences. And you can see how much more normal this is when we have a bigger input space. Makes processing time goes way up when we increase the size of the input space. So we don't want to get too crazy about this, but I could also, we could double this again and just show you. This will slow things down quite a bit. But now we've got a nice normal distribution right around that center point. So I want to show how we're doing this distribution. We're using something called a random Bates distribution, which we'll talk about why we're doing that, and we'll write about it too a bit. We're sort of outsourcing that. So let's revert this back to what we had before, and just make sure that we didn't break anything. So we should still basically get the same thing. It's just the distribution isn't quite so smooth, but that's what happens when you have a smaller sample size when you're doing random distributions. So I'm stating here for these diagrams, the connections are initially established in a normal distribution around a center point. But I'm not saying how, I'm sort of saying why, because it ensures the synapses are primed to either connect or disconnect quickly when learning, because they're close to the connection threshold. So let's look into some of this code and in the permanences. And this is actually going to be within simple HTML. So let me get that. Let me open that. I'm going to open up a version, our local version of simple HTML. Make sure I have the most recent copy of it. And I don't. I have some local changes. Well, I was trying to get this all nice so you guys could actually see it somewhat. It's, what are my local changes here? Oh, I just added some comments. I'm sure, I can actually do this. Look at this here too. Let's look at it here because it'll be a lot easier to see. So, I just added some comments in the tests. I added a test, a whole test here. So, man, I'm really bad at writing code in my desktop computer and then not pushing it and then writing the same code in my laptop computer. So what do we have here? We have an assertion. So from head, this is what's most recent in head. What have I done that's different? Assert, so I've got, I've created this expected value. And this is actually the newer thing. This is what I want, I think. Right. So I was just assuring the min and max were right. So I remember doing this in two places now. One way was a little cleaner than the other. Actually, let me, before I do that. Yeah, I want the local change, the one where I put it into an expected. I think that's cleaner. So that's what we want. And then here it's, I just added an extra test to make sure that the overlap arrays were matched, which seems acceptable to me. Now that we've done that, we should run test again and make sure nothing that these tests still run. And they do. They just take a little while. And then we'll go look at our permanences code. As if I had more than one mind. No, I just am very forgetful. I mean, I think I have less than one mind. I'm super forgetful. Okay, so let's change. What else do we have changed? That's these changes. These are staged to be pushed. Okay, so let me, right, I was in the middle of a merge, I forgot. So let me merge that. Okay, and then we should be good. Okay, git push upstream master. I'm not gonna bother with a pull request here. Let's make this a little bigger so we can see it. So we'll leave it at that. Now we should be back in a good state. Okay. So initial permanences, right? Here are, so we've got get permanences, but that doesn't mean that we've created them yet. So here's one of the things we need to talk about is this random Bates function. The random Bates function, I'm using a D3 JS version, random Bates, and here is the code. So I am essentially going to link to it, random Bates, right here. And I could also link to a Bates distribution, but what the Bates distribution allows us to do is specify a density, essentially, or a spread for the function, so that we can control the peak, how flat or how peaked this is. So I think what we'll do in the prose of the spatial pooler, I don't know why I'm looking in permanences. Pools, coding, spatial pooling, okay. Let's go down to permanences where we were writing. So here we go. Connections are initially established in a normal distribution around a center point. For the initial permanences, the connection threshold should be near the distribution center. This ensures that synapses are primed to either connect or disconnect quickly, ensuring more entropy in the initial state of the system. So I should say something here about the Bates distribution. I don't think I want to make a big deal about it. Like, I don't want to give it its own heading or anything, because this is just one way to do it. This is not even the way Nupic does this. I don't even know how Nupic does it. I think Nupic doesn't use a distribution. It just sort of randomly, it does, the important thing is that most of the connections are close to the connection threshold. In Nupic, I believe they're sort of random. You know, is the Bates distribution something that resembles the biology? I'm not sure. It makes sense that there would be a normal distribution, I would think, around this connection threshold. We have to think about this as just being a starting point. We're sort of bypassing. I would probably say we don't really know, but I think it's a clean way to do it. In that we have to start somewhere. In biology, you start as a newborn being, a newborn mind that learns nothing, or that knows nothing really, and has to learn everything. That's not where we want to start from. I think we want to try and initialize a system that has, and we're sort of pretending that it's sort of these dendrites, axons, whatever, have grown a bit. So I'm not totally sure how. I'm not totally sure, but I don't think it matters too much. As long as these permanences are mostly close to the connection threshold, meaning they're close to being connected. We want some of them to be connected already randomly, and some of them not to be connected. So we're going to center them around the connection threshold and create a distribution around them. That's the important thing. And if research comes out, we can change it. But even if it does, I'm not sure it's important. As long as, like, if this were just random, we could. I mean, yeah. If we just randomly had all them around 85% of them close to the threshold, it would work. The fact that we have this hill, this peak, it's not that important, but it's something Alex Lavin told me is probably the best way to do it, and he recently commented on the forum about it too, when I mentioned him. So that's what we're going to use. We're going to use this Bates distribution. So I'm just going to say there are many ways. Let's start with that. There are many ways we might establish initial permanences. But I think I've already said that should be near, for the initial permanences, the connection threshold should be near the distribution center. But the important I don't know, but the important thing, I mean, I'm not really writing this very well, but the important thing is to establish most of the permanences close to the connection threshold. Close to the connection threshold, and I sort of explained that why above. We will use a Bates, and I'm going to put this, I'll link this, Bates distribution. This is where I can link to Wikipedia. A Bates distribution, okay, which allows the flexibility to choose let's say which gives us a variable to change what's the word I want? The intensity of the curve, let's say, of the distribution curve. As you increase the, what do we call it here? What did I call it? The connection threshold? Oh, I don't even think I have it hooked up, do I? Connection distribution. Yeah, this is it. It's called connection distribution. Yeah, connection distribution. So as we change, and the what they call this in Bates is independent variables. As you increase the number of independent variables in the Bates equation, is that the right? Let's just say distribution. The peak of the curve becomes more prominent. Let's say that. And see this in action by changing this value here. Just want to see if this works. So as we increase this, the peak, yeah, the higher we get, the peakier it is. And if we go down to like 6, it's going to be flat, real flat. And we go down to 2, it's almost completely flat. 0 is like a flat line. Oh, I don't even let it go to 0. So, hello Lolly May. Nice to see you. As you can see, you show up in chat right here. You guys watching? I'd be really happy if you gave this video a thumbs up and certainly subscribe. If you subscribe, something will happen on the video. Your name and lights. So I got that idea from Twitch. So hit that subscribe button if you haven't subscribed, and I'm pretty sure something like will pop up on the video. A brain will come. Brains will come. Okay, so I'm gonna put this back to 20, I think. Or did I? Oh, that's really tight. See how hot? See how crazy it is? Isn't it called kurtosis? Kurtosis? I don't know. Kurtosis? I've never heard of that term. Probability theory, the measure of tailoredness. Oh, yeah, that makes sense. Of a probability distribution. Kurtosis. Thanks. I appreciate that. I learned something today. This is why I like live streaming, because I learn things from the audience. Kurtosis. So it's similar to concepts of skewness, so kurtosis. That's a good thing. Maybe I could link to this if this makes sense. Kurtosis of a univariate normal distribution is 3. Cool. Okay, so like, that's great. And I don't think it's said anywhere in here. Yeah, it is. Kurtosis. Awesome. Such generalized so short tail is 3. There, it worked. Thanks, Melex, for subscribing. Oh, it actually mentions you in chat too. I appreciate that. Whoops. Okay, so what I really want this to be is 25. The kurtosis. In the Bates, I'm not sure this is exactly the same, because in Bates they call it independent variable. Maybe I don't want to introduce a new term in this document. Maybe I will. I don't know. It's good to have a reference. I could also just put see also. Let's do that in parentheses. See also ahref kurtosis. Kurtosis. That's great. I love learning something new. See also kurtosis. Okay, so that's how we're establishing our distribution. One of the things I want to show is the actual code to do this. Whoops, I scooted down. So the code in create permanences is right here in the spatial pooler in simple HTML. So we do this. Oh, this is right. We do this one time up front when the SP is constructed. Then those are our initial permanences. From there, we'll never do this again unless a new spatial pooler is constructed. So this is just done once, and then those permanences change if learning is turned on. If learning is not turned on, they don't change. That's where they're at all the time. So maybe we should say something about that too. Yeah. Connections are initially established in a normal distribution around a center point. Okay, well, I'll just emphasize this by writing it in the next paragraph. So, I already said connection established. So we're going to put some code next, and then we'll show the distribution diagram. I think that makes sense. So I'm going to write one more paragraph to explain that this is done when the SP is created. We're going to write the code that is executed when the SP is created, and then we'll show the distribution diagram. Okay. Yeah, so I want to code block. Initial permanences. Initial permanence values are established once when the spatial pooler, let's capitalize this, pooler is initialized. These values will only change if learning is enabled. And again, more on this later. Below is the logic to use, the logic below. The logic below uses the D3JS. Let's link this. href D3JS Bates. What did I call it? Random Bates function. So I've already got this linked here. Random Bates function. Let's do this. Random Bates function, okay, to establish thresholds, not thresholds, let's just say the values, okay, and then let me put the link in. All right, so logic below uses a D3. So now let's add the code, and I'm gonna copy. Okay, so here's a code example. We're gonna have to create the code example in another file. I'm keeping the code examples in a different file. And so we will throw this in here. This is gonna be code example 2, establishing initial, let's say, and we'll leave Minicolumn initial permanence values using a random Bates distribution. Okay, code example 2, go for the code index at, code index at 1. And now let's go find that. That is, where's our code examples? Not in components, examples, no. Hold on, I gotta find out where I got them from. Code examples, spatial pooling. Okay, here it is. Ah, that was a place. That was just dense. Okay, so we want another code example. I might change the way this works, but this is working for me now. We're just gonna create code example 2. We're gonna create a string literal and put the code example there and just index it. So it'll just be the second one. And now we gotta go grab the code example from the actual spatial pooler. So all of these code examples are what's running behind the page. So that's something I'm really trying to adhere to. So for example, this is it. Get the permanence. First you need the potential pool. And I will explain this because there's a tricky bit to this, and it's that the the indices of these arrays, the arrays of the permanences, the permanence array for each mini-column matches its potential pool. So you can't depend on using the index of the mini-column to access its permanence value, because the permanence values are matched to the potential pools. Same problem with the potential pools. The potential pool is an array of indices, of mini-column indices. And so these permanences match that. They don't logically just count up, and they don't match one-to-one with each mini-column, because that's a bit of a waste of space. If you've got a small potential pool, you don't want to store lots and lots of basically permanences that don't exist. There are no permanences unless that is a part of the index is a part of the potential pool. Okay, so let's try this and just put this here and then clean this up. So I think we'll keep this, get potential pools. Let's just leave, we won't use this. We'll just say get potential pools. This is a code example. So for each, the Bates function, let me look at this again. If I go to this Bates function, right, we're essentially establishing it using a parameter to the SP that establishes what that kurtosis value is. Got a new word. I love having a new word to use. So I don't think I'm going to highlight this. I'm just going to essentially say, call this Bates, we'll call it random Bates. So we're going to call the random Bates, and this center value is, I think we won't talk about that either. All that does is allow us to move the center of the maybe I should put that in. We want to be able to move the center of the distribution. So if I move the connection threshold up, I might also want to move the center of the distribution up with it, because we want the center of the distribution to be at in the center of at the connection threshold. So maybe I will leave that, and we'll call this distribution center, because I think that's what I called it. Yeah, center of distribution here. Okay. Establishing mini-column initial permanence values. Go back down here. Permanence values using a random Bates distribution. So that's our code example. This is weird that my diagram is a little bit off, but that's okay. We'll deal with that later. Okay, so get potential pools. So the thing I want to note about this is what I talked about earlier, is that this method of creating the permanences aligns to the potential pool for each mini-column. It doesn't give you an array back that that has space for every single mini-column or every single input cell, excuse me. We're talking about one mini-column and how it maps to the input. So this function's not going to give you an array that aligns to the entire input. It's only going to align to the potential pool of this mini-column to that input, which saves space in the long run. It makes the code a bit more complicated, I guess, but I think that's okay. So I need to explain, I think I explained random Bates. Get potential pools, we've already got the code for up here. So assuming that this is how we're getting potential pools. What I do need to explain is the distribution center minus a half. And that's because the default distribution center is at the midpoint at a half. So if we move it, you know, I'm hesitating about this now again. I'm not sure that I want to explain this. I don't think it needs to be explained. Maybe not. Let's see. We'll see. When we come back, we'll see how confusing it is. And if the permanence is over 1, this is just a ceiling and a floor, basically. Oh, I guess I can use the JavaScript functions ceiling and floor, right? Instead of this. No. No, this is okay. Yeah, this is okay. I'm gonna leave it like this. It's simple this way, right? Falco, you could add that not each input connects to each mini column, just like the brain. Right. Not each. Yeah. That's a good way to put it. It's aligned to the potential pools array. All right, let's try and write something to that effect. Hey, oh yeah, I just noticed Dimitri, guy who just told me about kurtosis, joined our Discord. Thanks for joining, Dimitri. You can join voice chat if you'd like. I have it open. Let's see, random. Okay, so I misspelled random. Random. Where is that? Random. There it is. Random Bates. And that code doesn't actually look like code, does it? Yeah, I've got a lot of misspellings everywhere. That's okay. That stuff will be fixed at some point. Oh, I guess it is. Okay, that is code. I just was hoping this was formatted properly. Okay, next paragraph. Move on to the next paragraph. We've got our code example. Okay. And then we want to sort of further explain this a bit. Okay, the array returned by this function does not let's see. This function returns an array for each mini column, an array of permanences, of permanence values for each mini column. Each array defines how connected that mini column is toward the input space. These arrays are not how did you put it? Is not fully. These arrays are not fully are not indexed. Do not cover the complete input space. Let's say that these arrays do not cover the entire input space, but only the mini column's potential pool. In other words, do not expect to index these arrays by input space index. They in order, let's say, in order to find the input indices for each permanence index, let's say input index for each permanence value, you must go through the potential pool for the goes through the, you must inspect, let's say you must inspect the Minicolumn's potential pool, which matches the, you think I'm overcomplicating it? This was something that confused David when we were writing this code. So I thought I would be explicit about it. I don't think David's online because we're not doing real coding today. He jumps in when we're doing coding, not prose. So I don't know that he's online. But I'll if it's over, maybe there's a simpler way I can say it. I mean the crux of it is you can't index this by using the length of the input space. You have to go through the potential pool array. In order to find the input index for each permanence value, you must inspect the Minicolumn's potential pool. I mean, maybe I can just leave it. Maybe I can just not do the in other words. Maybe that's good enough. I can just say to get a permanence values input space cell, you must access the Minicolumn's potential pool. Something like that. So much text is not making it clear. Yeah. Well, we'll come back. Like I said, we'll always come back and try and simplify. Getting something out is good. Okay, so we have this. Oh, I should also mention there's actually I might just put this in the. Let's just put code comments in for this. Why did I close that? Where's my examples? Oh, this is not the right one. Okay. So let's just write code samples here. Ensure, let's just say permanence must be between 0 and 1. Simple, right? And I can even say permanence arrays match the potential pool. Put that. How does that sound? Okay, so we'll leave that there. All right, so I'm not going to talk about learning yet. I'm going to take all these values and just kind of move them down. I don't know where. Somewhere down here. Now we're going to talk about the Minicolumn competition. Okay, so I need some prose right under the Minicolumn competition to explain what it is. And this is where we'll talk about K-winners and introduce the idea of K-winners. Maybe K-winners, there's a Wikipedia page about it. Yeah, winner take all, that's what they call it. Winner take all, or K-winners, winner take all. K-winners take all. In many practical cases, there's not only a single neuron which becomes the only active one, but there are exactly K neurons which become active for a fixed number K. Yeah, that's exactly what we're talking about. Winner-take-all networks, in case of competitive learning. This is an RNN concept, but it's the same thing in spatial pooling. Okay, K winners take all, we'll say. So at some point we'll talk about that. But for now, let's try and get some prose going for this. Not here, but up here. Minicolumn competition, right here. Whoops. What happened? I switched files, I don't know why. Okay. So this is sort of like the crucial part, I think, of the K is just a variable. It's just the variable they use for a count. So it's just like the top K. It's just a math thing, you know. The main thing I want to get across here. I want like a 1-2 sentence summary of the Minicolumn competition. So I'm just gonna like throw out some word salad here, I guess, and try and make sense of it. The important thing is these minicolumns compete to represent the semantics of the input. Okay, minicolumns. And should I don't. Do I have to say? I could just say for each input, minicolumns compete to represent the semantics of the input. They do this by comparing their overlap scores. Did I talk about that yet? Overlap? Yeah. No, I haven't talked about overlap. Okay, so I have to talk about overlap. I haven't talked about overlap at all. Okay, so this may be another diagram. Because one of the things we might want to show, yeah, this may be, and maybe I can just do this by splitting up this mini-column competition diagram. Do this by comparing their overlap scores. What I'd love to show here is for each mini-column, if I select the mini-column, so not show the winners yet. So I'll come up with a version of this diagram that doesn't show the winners, but it shows a count of each, and this is where a pause is really useful. So let's also add a pause. I think I have a pause. I have a pause command somewhere. UI element. Where did it go? Data player. Toggle learn. Where's the pause? Where's the pause? Where's my pause button? I have a pause. Diagrams input, here it is. Player, no. Yeah, player. Data player, that's all it is, it's data player. Yeah, data player, okay. So this will pause the input. So I'm gonna add that right here as I start talking about mini columns. I'm just going to put it here for now because I want to be able to pause it. So let's pause. Okay, so now we're paused. Okay, so before I continue writing this, I think I'm going to update the diagram a bit. I'm going to create a version of the mini column competition that does not show the K winners yet. It only shows the connections that it like emphasizes basically all these connections, these blue dots. It just shows the blue dots. I think this is fine on the right. Maybe we can, yeah. I might update this a bit. I sort of want these circles to be even. Maybe I'll make the circle lines dotted. Okay, so I am gonna go into the diagram a bit. I'm gonna make a version of this that doesn't show the winners yet. Okay, so I think I can do that. So let's make this figure 4-1. And we're gonna call this overlap. Let's call it Minicolumn overlap. Minicolumn overlap. Minicolumn overlap. And what was it? Yeah. So, and this competition we'll keep down here. We might actually have another one. So what I'm going to do here is tell it show competition false, and then on this one we'll say show competition true. And now we'll go into the Minicolumn competition. Come on, get in there. And we'll have a new option. I'm not going to store it. So where's our update function? Here we go. Update, render inputs to base, render competition. So in the competition, there is a specific, is this the, okay, so I've got this. I thought I had, what I really should have here is a completely different renderer that renders just the boxes of the winning mini columns. In this case, I'm not doing that. I'm doing them all at once, and I'm deciding on for whether I'm gonna. No, that's not right. Stroke. Where's the overlaps happening? Overlap. This is in the mini columns. Hold on a second. Let me inspect this. I'm gonna dig into this and see what exactly I'm doing here. Not that one. Let's pause. Okay, right here. Inspect. So stroke black, stroke width 1.5. Yeah, so it's the stroke width. Is that the only thing? It's stroke black and stroke width. Yeah, so it's this winners. That's right. So, okay, so if winners includes, so now, so really all I have to do is say if, so I'm gonna pull out a constant here. Constant show competition equals this dot props dot show competition, and we'll just add that to the condition. If show competition and then this one, same thing. If show competition and winners includes, let me put the extra parens here. So now they should not show up. Okay, good. Not crazy about this, but I can refactor this later. I'll put it to do. Fix me. Refactor out winners into another group, basically. It'd be another group. Same for here. All right. Okay, so we're not showing the competition anymore. We're just showing, and now I want to go to the circles, and I want to make them even less prominent. And I'm going to do that by changing the stroke. Let fill equals none filled. Why am I calling this fill? This really should be stroke. What is the, okay, SVG stroke dotted. Stroke dash array. There's something simpler than that even. I thought there was something even simpler than that. Maybe not. Okay, so we can do that. We'll do it and we'll just do dash array. It's whatever, dash, stroke dash dash array. Stroke hyphen dash array. So I'm gonna make them all the same. So we're not gonna have a dynamic dash array. Stroke dash array. It's gonna be 2, 2, or just 2. I think that'll work. Yeah, there we go. So let's make it even smaller, even 1, maybe 1, 2. And the stroke width should be pretty small. 0.5. Just want to see what this looks like. This is the actual width, and that's pretty small. That's too small. So maybe 1. And let's do, instead of 1, let's do 1, 4. Then they'll be even harder to see. Not you. Maybe you could define what overlap is in prose, and then you know what you want to display in diagram. I'm sort of going the backwards way. I want to show the overlap and then decide what to write about it. Because I want to have a count up here. That's one of the things I'm missing is a count. This looks awful. Hold on. This looks bad. Maybe 1, 2. That's okay, I guess. Oh, what I don't like is on the full circles. So I am gonna have to make this dynamic. So I'm gonna have no width if no width. I'm gonna steal this fill, and I'm going to stroke width. So we'll say width equals default is gonna be 0. Okay, and if we're connected, then width is gonna be 1. Oh, whoops, the opposite of that. Stroke is 1 if it's, yeah, the opposite of that. You like the way I represent the winners in horizontal bar diagrams in HTML school videos. Yeah, that's a good point. That's a good point. We could certainly do that. We could certainly do that. Yeah. But that's a good point. So we could define what overlap is essentially by pausing this, by allowing them to pause it, select a mini column, and then dynamically show what the overlap score is for that mini column somewhere by counting, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. It's 20 for that one. And so I want to display that somewhere. When you click a mini column, it shows you the overlap score. And then what's the heat map is showing, Yeah, that's exactly what I'm planning on doing. I'm gonna tell them what to do, and I'm gonna embed the pause button in there and say, press pause for the data. Now go click a mini column, and then notice the overlap score that pops up. We're gonna put the overlap score right in the middle here. So let's do that right now. Let's add the overlap score. So we're gonna say if we're not showing the competition, we'll show the overlap score. And in the next one, it would be great to have, maybe we'll do that in like another diagram down at the bottom. Okay, now I'm sort of brainstorming about a new diagram that I want. But you're right, that was a good presentation, sort of the stacked, you could see. What I'd like to be able to do is associate like this mini column. So let's say we have a diagram. So I have to think about this a bit because I have limited screen real estate here. I can't make these any wider than this because I know there's just issues with. I want this to be easily embeddable. I want it to display on mobile, and so I need to keep these the same width. So whatever I add needs to be this width. So I'm thinking I'll put something under it, much in the same way that I put this under the others. And I can show that stacked diagram that you said horizontally instead of vertically, right? I think we could make sense of that, or maybe not. We're gonna have to play with that, but we'll think about that as we go along. But I do think that's a great idea. We should have that. Something like that, so you can tell exactly what's going on here. That was a good illustration. Okay, so for right now, let's get the overlap number displayed. These selections look bad, but I'll deal with that later. I want to display the overlap score right here, and we'll do it for both of them. I don't think that'll be too bad. Okay, so back to the mini column competition. I will create another function. So we've got render input, render potential pools, render connections. Right, render connections, render mini columns, render competition. Okay, input space. So this is going to be outside of this entirely. This dot render overlap score. So I don't have this yet. So we're going to do this based on the selected mini column, and we're just going to essentially render a number on the screen. So selected mini column should be in here somewhere, right? Select mini column, no. Yeah, it should be prop. So here's where we get, so I need to get the potential pool for the selected mini column, and that will get me the permanences. So I need this for the permanences. Okay, so there's going to be pools first, and then perms. Okay, so const pools equals that, const perms equal pools. No, that's not what, yeah, wait, I'm confused. This dot props dot permanences. I don't need to get the pools. I don't care. All I need is the permanences, and I'm just going to do a count. Okay, so hold on. Const overlap equals 0, and then we're just going to loop over this for each perm, and all we do is if perm is greater than this dot props dot connection threshold, overlap plus plus. So now we have the overlap, and now we need to put it somewhere. So it's sort of between these two, so I'll just put it here. It's going to be a text box. Let's class name overlap label. I'll just call it overlap. And then we can just simply say, gotta get this, root select, this dot root select the text. I'll put it up here. Overlap text, overlap. So we're just getting it out of the DOM. And then we'll say overlap text, text. Is it text? Text, overlap. I'm not sure this is gonna work. SVG text, this might break. That's certainly not gonna be in the right place at this point because I haven't placed it anywhere. SVG, wait, D3JS text, text, set text, text value, change text value, something like that. Text element. I know it's something simple. I always have to look this type of stuff up. For all you need is to set the inner HTML, right? So I thought it was just text. I thought you just called text and of any element, and it would set the, or was it? It might be HTML. Either way, this is not going to be in the right place. So let me inspect this and look for it. Find text. Nah, that's finding all these other text bits in the potential pool. That's not what I want. I put them in between these two, so it should be easy to find. It's in between mini columns. There it is. Text overlap 0, 0, 0, 0. So it's being set, but it's always set to 0. And it's not really being displayed in the right place, but we're gonna put it, let's set it, let's translate it over. White space, no wrap display block. It should be black, but it doesn't look like it's showing anything. Pause this. Yeah, it's not showing up. Why is it not showing up? It may be underneath. No, it's not underneath. I am just, oh, I know why. It's, I always forget about this. Text is anchored at the bottom left, so I have to move it down. Let me just move it to the right place. I can do it here. Let's do it programmatically. Let's do it with a translation. In which case I will steal a translation that I have for the competition. Don't I have a translation? Translate. There it is. Okay. Adder. So we'll get this text, we'll translate it. We're gonna move it down. We'll move it to half, and we'll move it down like another half, I think. The same thing. And we'll see where it lands. Oh, it went, okay, fourth. Whoops, wrong one. This one, fourth. Hello, Mark Brown. All right, so there it is, but I still need to like subtract, I don't know, 40. This is gonna be all sort of custom. Oh, wrong one. I keep doing my translation on the wrong thing. Let's do that. This should be here. Why do I keep putting it in the wrong place? All right, I just want to display the overlap score. Before we talk about K-winners, I want to make sure that it's clear what an overlap score is when we're talking about a mini column. So I'm sort of isolating that part of this diagram, but right now it's not working, which is probably just something simple I'm missing. I don't think it'll be hard. Oh, it's this bit. So let's see what's wrong with our permanences. Something's wrong right here. Props permanences for each. Oh yeah, I forgot. I have to go into it. Yeah, so these are all. So I need to get the permanences of the selected mini column. This dot props dot selected mini column. So that's it. I think that's all that's wrong. For each of undefined. Oh, it's not select mini column, it's selected. Why did it do that? Oh, I had a function called select mini column, I think. Overlap is read only. What? Why would you do that? Of course it's not. It shouldn't be. Okay, let's see that score change. There we go. That's not right. 71? No, I don't think so. I don't think so. It should be like around 20 or so. So this is way too high. It's probably just an indexing problem. 76. Yeah, this has got to be just an indexing problem. So I'm getting the permanences of the selected mini column, and for each permanence, there's got to be something wrong here. We'll find out. Okay, this permanence and the connection threshold. Ah, that's right. There's no connection threshold. Oh, I'm gonna pull this out. So let's pull this out of this function scope and set it up right here. Connection threshold equals. Now we don't have to worry about this. I bet this works better. No, it doesn't. Really? Where's my function at? Render overlap score is above select mini columns. But it's not in this. Back to the debugger. Connection threshold is 0.5. If the permanence is over 0.5, increase the overlap. So this should increase the overlap. We should have an overlap of 1. This looks right. That looks right. Maybe something didn't get updated properly. No, that's wrong. That's definitely wrong. Is it because I'm not resetting? Oh, this is active duty cycles. That's why I keep screwing this up. Okay. Okay, so start here. Start here. Nay, go away. That's not what I want. So overlap is 0. We go through our permanences. How many permanences do we have for this? 128. And they're all right around 0.5. There's one for every, wait, this isn't respecting the potential pool. This is, let me add this to the watch. Look up. Continue. Add to the watches. Okay, I did. Where are my watches now? Not navigator. There it is. Okay, there's my watch. So these are my permanences, and there's 128 of them, which is, it shouldn't be 128. It shouldn't be 128. It should be less than 128. Because that's, the potential pool is 85% of 128. The permanences are what I'm getting from, these should all be, they are different sizes. Okay, the selected mini column is what? 191. No, 190. Yeah, 191. Which has 128. Okay, that seems right. Okay, hold on. All I need to do is go to where I'm rendering the connections and make sure that I'm using the same logic, because obviously I've got something wrong in my head. Here's rendering connections. Where's the data coming from? We're calling this .props permanences selected mini column. We're getting selected mini column from this .props selected mini column, which is right. Okay. So that's our data on which we draw circles, and we are deciding, oh, the winners. No. If connection threshold and encoding pools. Okay, what's this bit? I forgot about this. Oh, right, the input bit has to be on. The input bit has to be on. So I'm not calculating that. So I'm just displaying everywhere that there's a possible connection. So this isn't an overlap. I'm not doing the actual overlap calculation. I'm just counting all of the connections that are above the connection threshold. I obviously have to also use the encoding. Let's split this down so I can go down here where I was working. I obviously have to use the encoding, okay, and make the decision whether it's on or not. And I have to get the pools. Damn, I do have to get the pools. That's okay. All right, so we're gonna get the pools. We're gonna need the encoding. We're gonna need the pools. We're gonna need the selected mini column. Okay. All right, selected mini column, encoding, potential pools for the selected mini column, And now we can add this bit, which is what we really need to do to decide whether we're going to count it as an overlap. Say if the permanence is greater than the connection threshold and the input bit is on. That should be it. I don't know why that was so confusing for me. That's basically the calculation we're doing. I is not defined. Right, because I'm not. Perm I. That should work. That's better. That's what I want to see. So if we pause, these should be high 21. This should be 7. 1, 2, 3, 4, 5, 6, 7. Good. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good. Okay. This is literally deep. Yeah. Okay. So we're showing the overlap score here. And I'll make this look nicer later, I think. But essentially, maybe I should. Okay. Yeah, let's continue writing the prose. We'll get there. All right. Close this guy. Back to the prose. Back to away from the mini-column competition. Where were we? Right. So they do this by comparing their overlap scores. I'm going to emphasize that because it's a new term. And overlap score denotes the how strongly a mini column matches the input. Denotes how strongly a mini column matches the current input. Just learn digging into. Yeah, that's that's exactly what what I'm planning on doing, Mark. And it's funny because in my head, I mean, it makes total sense. I just, in the code, I disconnected and didn't realize, oh, obviously I have to, it's not just the potential connections, it's the ones that overlap the current input. It's right there in the code. An overlap score denotes how strongly mini column matches the current input. In the diagram below, I'm gonna ask them to pause the data. Press the pause button. Boop. And inspect the diagram below by selecting mini columns in the left chart. Some reading over your shoulder will have to get that same hand holding. Let's see where I go with this, and you tell me if I don't go the direction you think I should go. Oh, I don't want that to break up like that. I'm gonna fix that. It should be easy. It's in components, input, player. Okay, so I don't want this to be a div, I want it to be a span. I hope that works. Oh my god. Whoops. Come on now. Oh. I think this is probably because my CSS is looking for a div player. Or is it because you can't give a span a width? Ugh. This is not what I wanted. Span class player. Yeah, so these SVG buttons. Oh crap. Okay. I'm not gonna mess with this. I'm gonna put it back. because apparently this is dependent, these polygon points are dependent on being inside of a block component. So I'm going to leave this and I'll just make a note to try and fix this. Well, it'll be pretty obvious, I think, that it's not what we want. Press this pause button and inspect the diagram below by selecting mini columns in the left chart. Pause, pause, select. As you select different columns, I'll say the redder mini columns have more overlap with the current input value than the green mini columns. As you click around the space, notice the overlap score, again, emphasis, overlap score changing. This is the value of the current permanences that I want to say connections. These are the connected synapses. I've already explained that. This is the value of, this is the number, say the number of connected synapses, okay, which means permanence is above the connection threshold, which has been explained previously. That's what I'm doing. I'm explaining the overlap score, definitely. That was the point of this whole thing, is to explain the overlap score. It's the number of connected synapses that overlap the current input, overlap the on bits in the input space at this time step. So you click through the count. You can verify this score. You can verify this score is correct by counting the number of solid blue circles in the input space. Notice they are all on top of a gray input box, which represents an on bit. Okay. Yeah, overlap is a verb in American English. I mean, to overlap something is to be on top of it, or to, like a Venn diagram, when you have two circles, they're overlapping. You know, where there's an overlap where the circles are both covering the same space. It's a common term in English, overlap. Like if you put two blankets on top of a bed, where they both covered the same space would be where they overlap. Okay, this is the number. Notice the overlap score changing, and I'm gonna better denote this score. I'm gonna put a label on it in the diagram. This is the number of connected synapses that overlap the on bits. Let's change that. Overlap the on bits. Of connected synapses that overlap the on bits. On bits in the input space at this time step. You can verify this score is correct. Let me pause it again. You can verify the score is correct by counting the number of solid blue circles in the input space. Notice they are all on top of a gray input box, which represents an on bit. All on top So connected synapses that do not overlap the current input are not counted in the overlap score, obviously, right? But I think it's okay to restate this. I really want to fix this so I can embed this pause button inside of the text. I'm not sure if that's possible with it being an SVG, but I wouldn't be against changing it. Okay. Okay, so now the next thing to explain is that these overlap scores are what we compare to decide which columns represent the data. Do not overlap the current input are not counted. Current connected synapses that do not overlap the empty circles. The empty circles did not overlap. Okay, you're just saying overlap the current input. Empty circles. That makes sense. Are not counted in the overlap score. Pause. Okay. Okay. All right. This next diagram I'm going to defer because I do like the idea of showing a stack, a ranking. So that would be the creation of another diagram. So I might put a placeholder in for that stack ranking. And then ideally, as you select one of the mini columns in the stack ranking, that becomes the selected mini column, and all the other ones update. So you can associate this one at the top of the stack as this mini column. So that's exciting to do that diagram. I'm looking forward to making that. So, but let's put a stub in for that. Before this one, there's going to be a stub, and this is going to be figure 4th. Wait, that was figure, yeah, where am I? 4-1, right, this is going to be 4-3. This is right, that's the one I want to keep. And so we're going to put a stub here, it's going to be 4-2. And we're going to call this stack rank, something like that. It's not going to be mini column competition. All this stuff, I'm just going to take that out and say diagram stub. Oh, I took it out. Import diagram, diagram stub from components, diagrams, diagram stub. Okay, there we go. Permanences, mini column competition, diagram stub, that, okay. Mini column, and then let's go down here. I don't know what this is gonna be like, but I definitely know there's gonna be a selected mini column coming out of it. To stack ranking of mini columns by overlap score. That's what that's gonna be. Okay. Why did I call this mini column stack rank overlap? It's supposed to just be called stack rank. Okay. So assuming that that exists, we need to introduce it. Here is another view of the mini columns. The columns ordered by their overlap scores. Those with higher overlap scores are and instead of being up and down, this is going to be left and right, I think. So we'll say closer to the left. Let's do left and then go down. We'll have the highest ones are the highest ones at the left. Left of the diagram, and yeah, left of the diagram. During the mini column, yeah, it should be clear when we get the diagram. Competition. During the competition, let's say competition. Mini columns with the highest overlap scores should represent the input data for this time step. So just to say should represent the input data. To choose the winners of the competition, fireworks, we simply we simply choose we choose how many I'm trying to say K. You know, we decide K. I haven't talked about K. I haven't talked about K winners yet. Yeah, happy 5th of July. Man, the fireworks were nuts last night near my house. There's these giant signs everywhere that say no fireworks, $1,000 fine for fireworks, and there must have been 50 people shooting off fireworks at nobody cared. Okay, so to choose the winners of the competition, we must decide. We decide how many. Let's just say we decide how many columns we want to represent the data, and simply cut off and simply choose that amount. How do I say that? We decide how many mini columns we want to represent the data, and I mean, what I want to say is we just like cut off the stack at that point. And I don't know, maybe it's simply, maybe that's what we do. What we do. We cut out the remaining mini cut the stack at that point. And this should be clear from the diagram because we'll have, first of all, we'll have a K, and so we'll be able to have a K, and we can move it back and forth. So I'll add that. I'll say in machine learning terms, this is called a K winners take all operation. And I'll link that to, where was it? Winner take all, here we go. K winners take all operation. Let's link it to href K winners take all operation. To we can easily control the sparsity of this new representation by changing k. Okay, so there's also something that we want to change. We've got winner count here. And I'm not using it for anything, but we should introduce something that changes this winner count and make it a state so that it can be changed. So let's do that real quick. We're going to make it a number value, and we'll call it kwinner count or something like that. We'll put it here. So let's call this kwinner count, number value k winners, low. Let's at least have to have, I don't know, 10. I don't know. Okay, 1, and we'll make the high. I mean, it can't be bigger than the input count. I don't even know what that is, so let's just make it 100. I don't know. And we'll step it at 1, which we don't need to do anything for. We might change this at some point. And we'll call this kwinner count. That's the state. So the set state kwinner count value. Okay, so first of all, I'm going to change this to kwinner count, and now I'm going to add it to the state here. We'll put it under permanence. Kwinner count 20. Get rid of this. And then everywhere we have kwinner count, we have to use the state. This dot state dot. There's another one that's already got it, and that's it. Okay, so now we should be able to use this kwinner count to change. This is where I love React. So now we can add this. Easily control the sparse representation by changing k. Try changing k here. Kwinner count. Let's see if it works. Try changing k here. Yes, it does. No, it doesn't. It's not working. I know why, I think. So when we're creating this Minicolumn competition, I think it might be, oh, this state.winners. We've already got winners. How are we getting this? Winners, undefined, winners. How are we getting winners? How are we setting that? Oh no, that's the actual winners, not the kwinner count, that's the actual winners. So how are we specifying to the Minicolumn competition? Am I in the right place? Yeah. Overlaps, winners. Oh, where we're calculating the winners, we're calling compete. So when we create the SP, initialize spatial pooler, size, input count, connection threshold, winner count. There it is. State kwinner count. Oh, I think I know why. Okay, so I have to have a in the component did update. I'm not always initializing the spatial pooler. I'm only initializing the spatial pooler if the connection threshold changes. I don't think I don't think I need to reinitialize the spatial pooler if k changes. All I really need to do is update the options. So winners, so before, so if there's no SP, I'll initialize, otherwise I'll say this.sp.ops.kwinnerCount. Let's go look at the spatial pooler and see how it's deciding how many winners. Calculate overlap. Where's the winners? Winner count. Okay, it's just winner count. So I should be able to, this is a little bit inappropriate intimacy. Fix me. Inappropriate intimacy. This.sp.ops.winner count equals this.state dot kwinner count. But I think it'll work. I can't tell. Is it working? Is there only 7? Is there 1? If I do this, is there 1? Yeah. Okay, so that's working. Great. All right, so we can change the k-winners. Good, good. So now we only have 8, and they're the very highest, the highest of the highest overlaps. But there's a tie-breaking problem here. We haven't really talked about tie-breaking yet, but there is a problem with tie-breaking here. But I'm not going to get into that quite yet. We'll probably talk about tie-breaking. Well, I mean, we have to at some point, I think. It's probably important enough. Right now, it's doing basically random tie-breaking. So I'm not going to mention it. All right. Here's another view of the mini-columns ordered by their overlap scores. Those with higher overlap scores are at the left of the diagram. During the competition, mini-columns with the highest overlap scores should represent the input data. To choose the winners of the competition, we decide how many mini-columns we want to represent the data and cut the stack at that point. In machine learning terms, this is called a k-winners take-all operation. We can easily control the sparsity of the new representation by changing k. All right. Okay. Guys, I'm gonna wrap it up now. It's almost 3 o'clock and my throat's starting to hurt from talking. So let's start a review of this code and see what we've done and where we're at. So first of all, I don't know why this image is here, so let's take it out. I know why it's there. It shouldn't be there. See Mark Brown. So on our spatial poolers page, we've added a diagram stub. We've extracted winner count from a global page variable into a state page variable. We've also added some inappropriate intimacy with our spatial pooler by setting its winner count without a setter. This is still the winner count. We added a number scrubber to change the k-winner count. And then we added some prose here, a code example for establishing mini-column permanence values. Yeah, permanence values. And then we started on the mini-column competition and broke it out into several different diagrams, one of which we haven't created yet. So before we go on, let's go and create a ticket for this. Oh geez, that's not ever what I want to do. I accidentally opened every tab in there. Okay. So looking at our projects, excuse me, figure captions, write prose, that's what I'm doing. Still have to do this. Do not display connections on permanence diagram initially. I may have fixed that. Okay, but let's add this. So create new diagram to show stack ranking of mini columns by overlap score. All right. And I'm going to turn this directly into an issue, convert it to an issue. I'm going to stage that. It's an important thing to do. And let's add the right labels. This will be an enhancement. It's going to be a D3. There we go. Okay. So we got that. Get rid of this, get rid of this, get rid of these links. Got these links taken care of. Okay, back here. Okay, Minicolumn competition, fire truck. Sorry, I missed it. We added a new function called render overlap score, and we changed some of the circle strokes. I changed the name of this one because it wasn't right, and then we changed the circle stroking. We added an option to show competition or not, and then our actual render overlap score. This is a bit inefficient because we're calculating these overlap scores twice. We're doing it here in render overlap score, and we're doing it in the mini columns, but so I could add a fix me for that too. Inefficient, because we're already calculating overlaps elsewhere. Just leave it at that. And that's where the text element is for the overlap. That looks good to me. And then we added a new code example. That all looks good. Okay. Filling out Minicolumn competition prose and adjusting diagrams. I don't really care that we're over the limit. We're pushing it. And here we go. Not simple HTML. Get push upstream master. Alrighty. Oh, Space Boy playing soon? You know, I'll try tomorrow. Yeah, I'll do it tomorrow. I'll be on Twitch tomorrow on my other account. We'll do a little guitar practice. I've been doing chord progressions, and so maybe we'll do some chord progressions. Okay, well, if you think of a better way to explain the K winners, this is all a draft, really, and I'm totally open to suggestions. Tour de France starts from your town. Are you going to go watch it? That sounds fun. Do you want to see my new toy? I got like the extra large Stream Deck. Look at all my icons. So that's fun. I just started setting it up. It's a whole lot better because I kept flipping in between screens to do things, and now I can do everything on one screen. So that's nice. So that's it. I am going to have an excellent weekend. I hope all of you have an excellent weekend. I could play the piano with that. I absolutely could. I could set up each button to play a different tone. It wouldn't be very efficient, but I've got this. Got the cow sound. And I've got this. Oh wait, that doesn't work. It's easy to. I still have many more buttons I can add, so we'll see. We'll see what happens. But the important thing is done. The important thing is definitely the cow sound. And once I get the sounds hooked up, so the chat bot, as you know, it doesn't work at all. It's not hooked up at all. It's a totally different API than Twitch. But I found the tutorials to get it. I know I can get it working and have it do everything that it did before. And I will add a cow sound so you can do, you know, bang sound cow anytime you want, Falco. You can make the cow sound. It'll be like Christmas every day. Thanks for joining, everybody. If you're watching, please like the video and subscribe to the channel. I would greatly appreciate that. And I will be back with a live stream Monday, research meeting live stream on Monday. In the meantime, I'm going to be working on thumbnails. So if you look at the YouTube channel, lots of new fancy thumbnails. I'm gonna keep working on that because people like to click on nice looking thumbnails for sure. All right, I'm gonna press this button on the Stream Deck, and if it works, the stream's gonna stop. So we'll see, and everything will be done. So take care, everybody. Have a great weekend.